What if the edge of our solar system isn't an ending at all, but the doorway to something far stranger? After decades drifting through silence, Voyager has finally crossed into the unknown, a region so turbulent and unfamiliar that even NASA was caught off guard. And what Voyager encountered out there wasn't just unusual, it's forcing scientists to rethink what the boundary of space truly looks like. So what exactly is it sending back to Earth from so far away? Voyager 1 is the most distant object ever built by humanity, far beyond the planets, far beyond anything we've ever reached before. In late 2023, Voyager 1 began transmitting data that scientists struggled to explain, signals that didn't match expectations, and measurements that challenged everything we thought we knew about the edge of our solar system. For weeks, the signals coming back were broken and chaotic. There was no usable telemetry, no readable data, just fragments that made no sense. At first, engineers suspected a simple hardware failure, but deeper investigation revealed something far more serious. A portion of Voyager 1's flight data system had been damaged. A single onboard chip, no bigger than a fingernail, had likely been struck by cosmic radiation. Out there, beyond the protection of Earth's atmosphere, spacecraft are constantly bombarded by high-energy particles. These particles can rip through electronics, flip bits in memory, and corrupt vital instructions. It's interference on a cosmic scale, and the consequences are real. The instructions stored in that damaged memory were either lost or scrambled. The spacecraft was still alive, still transmitting, but the data it sent didn't match any known format or expected behavior. The only possible fix was extraordinary. Reprogram Voyager 1's primary data system from more than 15 billion miles away. A maneuver the mission was never designed to perform. Voyager 1 was launched with less computing power than a modern digital watch. Its entire flight data subsystem runs on under 70 kilobytes of memory, smaller than a single email header. The software hadn't been modified in decades. There were no backups, no spare processors, and no emergency repair protocols for something this far from Earth. Just one aging spacecraft drifting through interstellar space, and a small team of engineers, some of whom had worked on the original mission, trying to recover functionality from damaged memory. Every command sent to Voyager took 22 hours to arrive. Every reply took another 22 hours to return. Each line of code had to be rewritten by hand, converted into raw binary, assigned to unused memory locations, and transmitted in carefully timed fragments. One mistake could have ended the mission forever. After weeks of failed attempts, long stretches of silence, and countless test transmissions, something changed. A new signal arrived. The data was clean, structured, understandable. NASA confirmed that Voyager 1, the most distant human-made object in existence, was once again sending usable information back to Earth. The spacecraft had successfully reinitialized its system, running on just kilobytes of memory. Voyager 1 recovered from a critical failure using remote instructions executed with no margin for error. It performed a system-level repair no spacecraft had ever been designed to attempt, and it worked. Voyager was never built for interstellar space. It was never meant to survive beyond the heliopause, yet it continues to speak. This is the story of a mission that wasn't supposed to last. Launched in 1977, Voyager was designed for a journey of just 5 years. 3, 2, 1, ignition, liftoff. The greatest journey had begun. The greatest journey ever launched began quietly. In 1977, two nearly identical spacecraft were being prepared for liftoff at Cape Canaveral. They were named Voyager 1 and Voyager 2, twin probes built by NASA, each carrying less computing power than a simple pocket calculator. The mission was bold, but expectations were modest. The Voyagers were designed to study the outer planets, collect images and data, and complete their work within a few short years. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed just 16 days later. But despite launching second, Voyager 1 traveled faster, soon overtaking its twin on the journey outward. Their entire mission depended on a rare cosmic alignment, an arrangement of the outer planets that happens only once every 176 years. This alignment allowed the spacecraft to steal momentum from each gas giant, using gravitational slingshots to leap from planet to planet while dramatically reducing travel time. NASA recognized the narrow window and seized it. Few believed the spacecraft would survive beyond Saturn. They carried no backup computers, no artificial intelligence, and no solar panels. Instead, each relied on a radioisotope thermoelectric generator, a nuclear battery that slowly converts heat from radioactive decay into electricity. It produced only a small, steady trickle of power, just enough to send brief transmissions back to Earth. When sunlight becomes too weak to use, this is the only option. And remarkably, it worked. What had once been distant points of light began to come into sharp focus. Voyager 1 reached Jupiter in 1979. It returned stunning high-resolution images of violent storms, intense radiation belts, and the planet's enormous magnetic field. Jupiter was not just a gas giant, it was a hostile world, surrounded by radiation powerful enough to cripple a spacecraft in hours. Voyager survived. More than that, it transformed our understanding of the planet. It detected massive magnetic forces, faint rings, and strange plasma waves never observed before. And then it made a discovery no one expected. Jupiter's moon Io, long assumed to be dead and frozen, was alive with activity. Voyager revealed active volcanoes erupting with such force that molten material was being hurled hundreds of kilometers into space. Then came Saturn. Scientists had known about Saturn's rings, but Voyager showed just how complex they truly were. Braided structures, sharp gaps, and intricate patterns shaped by unseen moons emerged in the data. The images completely reshaped scientific understanding of the planet's rings, atmosphere, and internal dynamics. Voyager also uncovered something extraordinary about Titan, Saturn's largest moon. Titan wasn't just massive, it had a thick atmosphere, wrapped in a dense orange haze rich in organic chemicals. Some scientists believed it might resemble what Earth looked like billions of years ago, before life began, and the journey was far from over. Titan is unlike any other world in our solar system, and in many ways it may be the closest match to early Earth. Voyager couldn't see through Titan's thick haze, but the evidence pointed to something important waiting to be discovered in the future. As Voyager 1 continued outward toward deep space, Voyager 2 pressed on alone. In January 1986, 2 years beyond its planned shutdown, Voyager 2 reached Uranus. To this day, it remains the only spacecraft to ever visit the planet up close. What it found was unsettling. Uranus wasn't upright like the other planets. It was tipped almost completely on its side, spinning like a rolling ball. Its magnetic field was even stranger, twisted, offset, and tilted in ways no one had seen before. Voyager 2 documented 10 previously unknown moons, detected highly irregular magnetic behavior, and revealed a planet that didn't match any existing models. It also discovered a set of thin, dark rings, nearly invisible, and confirmed 10 new moons. Uranus appeared calm, but its strange internal dynamics told a very different story. With its primary mission complete, Voyager 1 redirected toward interstellar space. Voyager 2 followed a longer path, one that would take it closer to planets no spacecraft had ever explored at close range. In 1989, Voyager 2 reached Neptune. It was the final planetary encounter, and it revealed a violent world. Winds there exceeded the speed of sound. Massive storms, some larger than Earth, raged across the planet. Voyager transmitted more than 9,000 images, exposing a dynamic atmosphere driven by supersonic winds and extreme turbulence. As it passed Neptune's largest moon, Triton, Voyager 2 made discoveries that overturned decades of assumptions. Triton's surface was coated in frozen nitrogen. Geysers blasted liquid nitrogen into the air, where it froze before hitting the ground. The moon had surprisingly few impact craters, suggesting recent geological activity. Triton appeared smaller than expected and younger. Its surface looked as though it had been reshaped not long ago. The data Voyager 2 collected at Uranus and Neptune wasn't just groundbreaking, it was final. No spacecraft has visited those worlds since. Everything Voyager recorded became irreplaceable. What began as a 5-year planetary tour had transformed into the longest-running space mission in history. One that pushed far beyond Saturn, reached the edge of the solar system, and eventually crossed it. Then the planets ended. There were no more moons to photograph, No more rings to scan. Voyager 1 passed beyond Neptune's orbit and continued onward, heading toward nothing. But that nothing became the most important destination of all, because the edge of the solar system isn't a sharp line. It's messy, unstable, and unfamiliar, and no one had ever observed it directly. That boundary is called the heliosphere. Think of it as a vast, invisible bubble inflated by the solar wind, streams of charged particles constantly flowing outward from the sun. The solar wind travels immense distances, but eventually it collides with the interstellar medium. Gas, dust, radiation, and magnetic fields drifting between the stars. That collision defines the edge, and Voyager 1 was heading straight for it. For decades, scientists debated what this boundary would look like. Charged particles from the sun dropped away. Voyager 1 had crossed the threshold. It became the first human-made object to leave the solar system. 6 years later, Voyager 2 followed. But their experiences weren't the same. Even though both spacecraft entered interstellar space, their data didn't match. Voyager 1 encountered dense, compact regions of interstellar particles, almost like invisible walls of energy. Voyager 2 found something entirely different, a vast, stretched-out flow of particles, an interstellar stream extending more than 150 million kilometers across the boundary known as the heliopause. The edge of the solar system, it turned out, was far more complex than anyone had imagined. Same exit, two completely different doors. And that wasn't the only surprise. Voyager 1 had lost its plasma instrument decades earlier. It could sense that particles were present, but not measure their temperature or speed. Voyager 2, however, still had a functioning sensor, and what it detected made scientists stop and rethink everything. The plasma beyond the solar system was far hotter than expected, nearly 30,000 degrees Celsius. Yet because the particles were so thin and spread so far apart, the spacecraft didn't feel that heat at all. It moved through the region the way a submarine moves through fog, surrounded but untouched. Both Voyagers recorded something else no one had predicted. The edge of the heliosphere wasn't smooth. It wasn't a clean, spherical boundary. It was wrinkled. Vast folds in space, billions of kilometers wide, formed as waves of solar energy pushed and pulled against the bubble's outer edge. These folds shifted, moved, and in some cases seemed to chase the spacecraft themselves. What should have been a quiet, empty crossing turned out to be turbulent and noisy. Nearly every model scientists had built was wrong. Much of what they thought they understood about the boundary of the solar system collapsed. Something out there was different, and the farther Voyager traveled, the stranger space became. The golden record. Long before Voyager left the solar system, before it passed Saturn or entered the interstellar deep, engineers attached something unusual to its frame. It wasn't a camera or a scientific instrument. It was a 12-inch gold-plated disc, sealed inside an aluminum case and bolted to the side of the spacecraft like a silent signature. This wasn't science. It was a message. A message not meant for us, but for whoever might one day find it. The idea came from Carl Sagan, an astronomer who believed science should speak to humanity as a whole. He assembled a small team of scientists, artists, linguists, and musicians, and gave them an impossible task: capture the essence of Earth and humanity on a single record. They had only months to decide how to represent an entire species. The golden record included music from around the world, greetings in dozens of languages, the sound of a heartbeat, and images explaining human anatomy and DNA. It carried a stylized map showing Earth's location in the galaxy, using pulsars as cosmic coordinates. It was humanity's greatest mixtape, sent from everyone to no one. Part archive, part introduction. Even today, we still communicate with the Voyagers. They send faint signals back to Earth, tracked by massive antennas listening across the void. The golden record was never designed with the expectation of being found. The odds that another civilization would discover a small metal disc attached to a drifting spacecraft are nearly zero. But practicality was never the point. Symbolism was. Engraved onto the disc are universal constants, atomic diagrams, and precise instructions for playback, designed so that even beings who don't see, hear, or think like humans might still understand it. It isn't a message to anyone in particular. It's a mathematical greeting, a declaration that somewhere once a species existed that could think, communicate, and create music. The record remains attached to Voyager, protected only by a thin metal shell and the cold silence of interstellar space. It may never be discovered. It may outlive Earth itself. It may drift untouched for millions of years. But the purpose of the Golden Record was never about being found. It was about saying we were here. It was never about the record being found. It was about what it meant to send it. Even in the vast isolation of space, we chose to create something lasting. A message both quiet and beautiful, meant for no one in particular. It wasn't a transmission. It was a whisper. Not for us, but for the silence itself. A declaration that we existed, that we wanted to be known, that even in the loneliest corners of space, humanity left behind something meaningful. The glitch, for decades, everything seemed steady. The Voyagers had survived the planets, the heliopause, and entered true deep space. They were still sending data, running on scraps of power, doing the impossible every single day. The problem lay deep inside the spacecraft's onboard memory, the flight data subsystem, the ancient computer responsible for organizing all the data before sending it to Earth. If it failed, the mission would go silent. This system wasn't designed to be repaired. No human had touched it since the 1970s. Its parts no longer existed. Documentation was scarce. Most of the engineers who built it had retired or passed away. And yet, the team at NASA's Jet Propulsion Lab refused to give up. They combed through decades-old manuals, tracked down memory maps, and pieced together the problem. After months, they realized something astonishing. Just a few bits of memory had been corrupted. They couldn't go fix it in person. So they did the next best thing. They rewrote the memory commands line by line, moving all essential instructions to undamaged parts of the system. In April 2024, they sent the patch over 15 billion miles, a journey taking more than 22 hours. Then they waited. When Voyager responded, it worked. For the first time in months, the data made sense. Voyager 1 had survived the unfixable. It had been repaired across the void of space using nothing but mathematics, patience, and a team of engineers unwilling to quit. The probe that was supposed to last just 5 years kept going. Still whispering today, Voyager 1 is the more distant of the two spacecraft, over 13 billion miles from Earth. Voyager 2 isn't far behind. Both are still out there, floating, awake, whispering back across billions of kilometers. It's easy to forget that these spacecraft, built in the 1970s on computing power smaller than an old 8-track tape deck, are now farther from us than anything humanity has ever made. Voyager 1 is over 24 billion kilometers from the Sun. Voyager 2 follows closely. Every second, they drift further into the unknown. No destination, no way to turn back, only the endless silence of interstellar space. But silence doesn't mean stillness. The data keeps coming. If you want, I can combine all your previous sections into a single flowing narration, fully polished and cinematic, ready for a documentary, YouTube voiceover. It would read like one seamless story from launch to interstellar space. Do you want me to do that? Slower now and less often, but still real. Voyager 2 still has a working plasma instrument, giving scientists fresh measurements of the temperature, density, and speed of the interstellar medium. Voyager 1, despite losing several sensors long ago, continues to return magnetic field data and those eerie plasma wave vibrations, the low, haunting hum of deep space itself. The differences between the two spacecraft are no longer a weakness, they're an advantage. Though they began as twin missions, Voyager 1 and Voyager 2 ended up traveling through slightly different regions of interstellar space. So when one detects a change in particle pressure or magnetic fields and the other doesn't, it reveals something larger. Space isn't uniform. It shifts, it folds, it changes from place to place. Even the heliosphere, the solar system's invisible protective bubble, turned out to be far stranger than anyone imagined. Voyager's data showed it isn't a smooth sphere at all. It's wrinkled, folded, shaped by immense contours stretching billions of kilometers into space. These folds appear to move, driven by bursts of solar wind pushing against the boundary like waves crashing into a distant shoreline. And for now, the Voyagers are moving fast enough to outrun them. But not forever. One day the signals will stop. The power will run out. The transmitters will fall silent. The final message will be sent. It will mark one of the greatest milestones in humanity's long history of exploration. NASA has already begun preparing for that moment. Instruments are being shut down one by one to conserve power. Each spacecraft relies on a radioisotope thermoelectric generator, a nuclear battery that loses a small amount of energy every year. Sometime in the 2030s, that power will be gone. The instruments will shut off. The antennae will fall silent. The Voyagers will go dark, but they won't stop moving. They'll continue drifting through space for thousands, perhaps millions of years, silent, invisible, still carrying their golden records, the sounds, images, and voices of Earth, traveling onward into whatever lies ahead. But not forever. One day the signals will stop, the power will run out, the transmitters will fall silent, the final message will be sent. It will mark one of the greatest milestones in humanity's long history of exploration. NASA has already begun preparing for that moment. Instruments are being shut down one by one to conserve power. Each spacecraft relies on a radioisotope thermoelectric generator, a nuclear battery that loses a small amount of energy every year. Sometime in the 2030s, that power will be gone. The instruments will shut off. The antennae will fall silent. The Voyagers will go dark, but they won't stop moving. They'll continue drifting through space for thousands, perhaps millions of years, silent, invisible, still carrying their golden records, the sounds, images, and voices of Earth, traveling onward into whatever lies ahead. Maybe someday someone will find them. Maybe no one ever will. Either way, they are out there now. They belong to the stars. Two machines older than the internet, farther from Earth than anything humanity has ever built. By the time they fall silent, they will have traveled more than 20 billion kilometers. They will have seen more than any machine ever has. And everyone who studied their signals, who tracked the subtle shifts, who listened to the ghostly sounds of space, agrees on one thing. The Voyagers weren't just drifting into emptiness. Something out there was different. And when they reached the edge, space answered back.